Welcome to the video lecture series on digital signal processing. In this video lecture, we can see the continuation of problems in Z transform. Previously, we have discussed four problems. In this video, we can go on to the next problem. In this first one is to find Z transform of the sequence x of n is equal to minus the 1 by 2 the whole power n u of minus n minus 1 minus 1 by 4 the whole power n u of minus n minus 1. Both these are in the negative region. We know the Z transform formula is minus infinity to infinity x of n is z power minus n. So on substituting the value of x of n directly, we'll get the expression like this. And changing the limits, applying the limits, u of minus n minus 1, as I have discussed in the previous video, the limits changes uh, s- based upon the appearance of unit step sequence. Here, this unit step sequence will lie in negative region. I have already said you minus n minus 1 can be equated to 0. So we'll get n is equal to minus 1. Since it is in my time reversal format, that is minus n format, the signal will be starting from minus 1 and it will be available at the negative side in this axis. From minus 1, the signal will be available with amplitude, unit step sequence will be available with amplitude 1. So we are changing the limit like this, minus infinity to minus 1. Interchanging the limits to 0 to infinity, we have to separate by minus 1. So this deeply we have discussed in the previous video. On simplifying this, we will get 2 minus 1 by 2, 1 minus 2 z by minus 1 by 1 minus 4 z. So coming on to ROC, here we have two signals, 1 by 2 power n and 1 by 4 power n. So ROC will be for ROC1 for this case, ROC2 for this case. Let us see 1 by 1. ROC1 will be less than 1 by 4 because 1 by 4 power n u of minus n minus 1. This will give ROC for less than 1 by 4. For 1 by 2 the whole power n u of minus n minus 1, the ROC will be less than 1 by 2. So the final ROC, which is the intersection of ROC 1 and 2, is it is less than 1 by 4, this one. So this is the final ROC. So when we have two signals, we have to see the intersection of ROC of both the signals and we have to finalize the ROC. In this, the two signals are 1 by 2 the whole power n and 1 by 4 the whole power n. Coming on to the next problem. Here, what is the difference between the previous problem and this one? This problem is it has both signal. This signal will be in positive axis. This signal will be in the negative axis. So for this, while expanding using this is the general Z transform, just applying x of n inside the formula. One will be from 0 to infinity, next one will be from minus infinity to minus 1. On simplification, we get this. If we draw, this particular will be from, it will start from minus 1, 1 by 2 the whole power, 1 by 2 the whole power minus 1, 1 by 2 the whole power minus 2. It goes on like this. Sequence will be starting from minus 1, whereas 1 by 4 the whole power n will start from 1 and it will be 1 by 4 means 0.25, right? So it will be starting from 1, it will be the sequence will be decaying like this. So the final expression after using the Z transform formula and simplification, we are getting it. Here also you will get the ROC for this one, ROC1 and ROC2. For this, it will for ROC1 will be greater than 1 by 4. ROC2 will be less than 1 by 2. So the region of intersection will be, this is ROC from 1 by 4 to 1 by 2. This will be the final ROC for this particular problem. So this sequence has right side as well as left side. Coming on to the next problem. So this is another similar problem, greater than a and 1 means. So we will get another problem also like this. X of n is equal to a power n. Here a power n, for n greater than 0 it is a power n a power minus n for a n less than 0. Again by applying the z transform formula and substituting, we will get one from -1 to infinity, minus infinity, and another for 0 to infinity. So this is in the positive side sequence, this is the negative side sequence. So just again by application of the same formula, we'll get like this. So you'll get two different ROC, one z less than a and z greater than a. So ROC for the problem 7 is ROC1 will be less than 1 by a, ROC2 will be z greater than a. So the final ROC will be between a and 1 by a. Coming on to the next problem, here we have to find the z transform of x of n is equal to sine omega naught n u of n. We all know that sine theta can be represented in terms of e power j omega naught n minus e power minus j omega naught n by 2j into u of n. So when we apply the z transform expression again, you can see this is the general formula. Instead of x of n, it is sine omega naught n. Instead of sine omega naught n, we are going to replace this term. So just replaced. Again, u of n is available. So infinity, the limit will changes from 0 to minus infinity to the infinity to 0 to infinity. And splitting these two components into two summation, we'll get like this. Taking 1 by 2 j omega outside and making this as a common term and bringing this n outside and applying the geometric series formula, we'll get like this. 1 by 1 minus e power j omega naught z inverse minus 1 by 1 minus e power minus j omega naught z inverse. On simplification of this, we'll get as z by z minus e power j omega naught minus z by z minus e power minus j omega naught. Further on simplification, cross multiply the given expression, and on grouping we'll get z sine omega naught by z square minus 2z cos omega naught plus 1. ROC for this is z greater than a. Coming on to the next problem, instead of sine omega naught n, if we take cos omega naught n, we all know that exponential formula for cos omega naught n is like this. Again on substitution, we'll get the final answer similar to the previous problem. The few problem for task is r power n sine omega naught n u of n, which you can try. Similarly, r power n cos omega naught n u of n is another task for the day. You can try and solve it. These were the references. Thank you. Stay tuned.